Welcome to this presentation brought to you by the team behind Project LinkGate at Bibliotheca Alexandrina and the National Library of New Zealand. Let's talk about visualizing data that's linked together at scale. My name is Youssef Eldakkar, Head of Department for the International School of Information Science, part of the BA-ICT. Special thanks to the BA Information Network's YouTube channel for hosting this presentation. Let's first talk about just linked data. Linked data is structured data that's linked together so it becomes more useful. If we think about it, we do this every day. We often need to link different pieces of data together in order to understand something. Data can get very big and complex. Complex things are often easier to understand when we can visualize them. There are lots of examples of linked data all around us. Let's look at some of the examples, but also please take a moment to think of some of your own. Let us know what you come to. Your family tree. Imagine plotting your family tree going back a few hundred years. Imagine doing this for everyone in your town, for the whole world. It can get very big. How we classify living things in biology is an example of linked data. At Bibliotheca Alexandrina, we have first-hand experience with this as part of the Encyclopedia of Life project. Financial transactions, especially with today's digital economy, are also an example of linked data that can grow very big. Bibliographical references. We are a library, we have books. Books refer to other books. This is also true for scientific papers and also for Wikipedia. Articles in Wikipedia refer to other articles in Wikipedia and to external links on the web. This is a very popular one. Social media. Our friends, how we're connected to them and to people we know. The street network is also an example of linked data. We traverse a big network of linked data when we move from one point to another on a map. A very interesting one is historical events and how they are interrelated and how one event leads to another, to another, to another. And we come to the internet. In 1992, it was rather simple compared to today, but it's still made of several computers connected together across different routes. The internet gave us the World Wide Web, web pages, websites, which gave us in turn the inspiration for Project LinkGate. Before we continue, let's talk about what's a web archive. A web archive is an archive of older web pages. Traditionally, it's accessed through a Wayback Machine that allows us to browse the web that used to exist in the past. A web archive can get very big, hundreds of terabytes or even petabytes, and billions of links. At Bibliotheca Alexandrina, we have been involved in web archiving since 2002. In 2011, we joined the International Internet Preservation Consortium, working with other institutions around the world to preserve the web for future generations through web archiving. This year, together with the National Library of New Zealand, we started working on Project LinkGate for developing software to visualize linked data in a web archive as a graph. In the project, Bibliotheca Alexandrina is leading development, and the National Library of New Zealand is working with the community to compile an inventory of research use cases for web archive graph visualization. There are tools already in existence for graph visualization. One very good choice is Giphy. In this project, however, we are focusing on scaling up to very large data as typical of a web archive. We're also focusing on accommodating the versioned nature of data found in a web archive, where each element can have multiple copies belonging to different points in time. Today's internet is much bigger than the internet we saw a few slides earlier of 1992. A graph of linked data in a web archive can get very complicated and can also make for a very good wallpaper for your desktop. The National Library of New Zealand has been working with the community to identify research use cases for a visualization software that's designed for web archives. Use cases identified include tracing how information flows on the web and also understanding patterns in complicated graphs, commonly referred to as fuzzy hairballs. The use cases are maintained online, and we always welcome contributions. In 2016, Bibliotheca Alexandrina developed an earlier graph visualization tool, the Crawlog Animator, for visualizing the process of capturing web pages to include in a web archive. In Project LinkGate, we're taking it a step further to scale up to a full web archive and equip researchers with the tools to explore the linked data. The design is for 3 modular, interoperable software components: a data service, an extraction tool, and a visualizer. Let's now look at these components. Let's start with the data service, which in the design sits in between the other 2 software components. LinkServe. This software component provides a programming interface for inserting and retrieving versioned linked data. Under the hood, it manages an underlying graph data store, which is a special kind of database intended for linked data. The design of the LinkServe data service aims to allow for scaling up to hold very large amounts of data, to capture the concept of data elements having multiple versions, to provide a convenient programming interface for interoperability and compatibility with other graph visualization software, namely Giphy, and to be based on publicly licensed technologies. This software component, as well as its other 2 friends, which we'll see next, are developed as open source software, which you are welcome to check out. This is how the data schema used in LinkServe looks like, which again is designed to capture the concept of multiple versions per data element. And this is a screenshot showing the Giphy graph visualization software working with our LinkServe data service as its source of data. Let's next see the indexer. LinkIndexer is the data extraction tool that operates on the origin dataset from which linked data is to be extracted and sent to the data service to store. In this phase of the project, LinkIndexer knows how to work with only web archive datasets, but it's designed such that it may be extended to support other types of datasets later on. The tool is also designed with focus on efficiency, since it's expected to operate on a lot of data, very likely in a distributed computing environment, and once again, this is open source software that's publicly available. Here, this is LinkIndexer in action, running through web archive data and sending to the data service. Let's finally see the visualizer. Our visualizer goes by the name LinkViz and is the web-based front end to link data stored in the data service. The visualizer is where users view and explore linked data as a graph consisting of nodes and edges. The visualizer is aware of data elements having multiple versions. We plan to build into LinkViz the means to extend its functionality through plugins, finders, and visors. Finders for exploring patterns in the graph, such as the Path Finder for finding all paths from one node to another, and the Loop Finder for finding all loops through a node. Also visors for enhancing the graph visualization, such as the GeoVisor for overlaying graph nodes on top of a map of the world according to geographic location. This is also developed as open source software. This is an early prototype of LinkViz showing snapshot selection. In other words, selecting a version of the graph to navigate to. And this is a graph visualization. Project LinkGate is a work in progress, so please stay tuned for updates on the blog of the International Internet Preservation Consortium, the IIPC. And please get in touch.